What that means in the case of Spectre is that if you have JavaScript running in a browser that it's supposed to be a safe language, you can nevertheless take some small array in JavaScript plus an index that's very far out of the bounds and use that combination to read any byte of memory, breaking the safety that JavaScript is supposed to provide and causing pages that are running different JavaScript code all in the same process to be able to see each other. To fix this, JavaScript implementation either has to turn off speculation somehow at the CPU level, which makes things very slow. All of that speculation and caching is there for a reason. It can generate code that makes this less likely to happen, but that means you have to make extra instructions and make the code slower than it would be. So again, the cure can be worse than the disease in many cases there. A general thing that can be used to address this problem is to reduce timer resolution. That is, make it so that the clock that programs have access to is not precise enough to tell the difference between cached and not cached. But it turns out that this merely makes the problem harder. It just means that you have to do more work to have enough cleverly constructed code to be able to check the timing difference. It doesn't matter how poor your timer is. It turns out you can make programs big enough to detect the difference. The most practical solution, and the one that's mostly in place at this point, is out of the hands of the JavaScript engine implementation or other language runtime, but instead just have the hardware at the CPU level detect and mitigate against this kind of attack. So modern processors include measures to prevent leaking information through speculative execution.